Hello everyone, I am Srishti and today I am excited to share our project Impact of Dataset Size and Distillation Techniques on Image Captioning Performance. Imagine teaching a child how to describe photos. Would you choose to show them 10,000 photos or could they learn just as well with just 2,000 carefully chosen ones? Think about it and I think you'll get the answer. What is image captioning? It is when computers are taught to describe a picture using natural language, like saying a cat is sitting on a chair or as this photo suggests, a dog wearing glasses. You've seen it whenever Google Photos auto tags pictures or Instagram suggests text for an image. You must be thinking, what's the problem? The problem is that training powerful captioning models usually need massive datasets and heavy duty GPUs. It's a bit like asking a student to read every book in a library before writing a short essay. It's slow, expensive, and sometimes unnecessary. We asked, can we train strong captioning models with less data if we pick smart examples? We tested three models, ResNet 50 plus LSTM, next one is GIT, and third one CLIP with a lighter version of GPT-2. We trained the model on the MS COCO dataset at 25%, 50%, 75%, and 100% scales. To pick which images to keep, we tried two strategies. First one is random sampling. This is like picking images randomly, like drawing names from a hat. And second one is gradient based distillation. This is like picking the hardest example, like focusing on the trickiest exam questions first. Now, Arunava will walk you through what we discovered and why it really matters.
Thanks, Srishti. Our approach looks to utilize less data to get better results in comparison to existing works utilizing large amounts of data. We are integrating data distillation in our architecture. Finally, we have compared multiple models across varied dataset sizes and distillation methods in our approach. Coming to the model, like what we have understood is that the choice of model makes the biggest difference. Consider the models to be children who have been taught a particular subject matter and now are being evaluated on what they have learned and how well they are able to perform in the tests. A cutting edge model called Git dramatically outperformed simpler models like GPT at ResNet 50, generating captions that are almost human like in nature in terms of detail and accuracy. As I said in the previous slide, Git provided us with the best results. As you can see, the caption generated from the Git model provides us with a caption that accurately describes what the image is in comparison to the other two models. Coming to the results, we have observed that using only 75% of the training data gives us as strong as results as utilizing the full data set. It's a bit like studying only important chapters during the for the exam from a textbook, but still getting an A plus. This suggests that more data isn't always better. Smartly selecting data can also be just as powerful in terms of yielding results. When it comes to distillation methods, as Srishti has explained previously in the presentation, gradient based distillation is where we are focusing and prioritizing how we are selecting the data. But this ultimately does not yield us with much improvements in results in comparison to random sampling. Since the results is not much, we have come to the conclusion from that. The conclusion is that we are utilizing a data set that is of very less size. We have utilized 5,000 images. So in this setting, model architecture mattered far more than how we are exactly sampling the data. Now, why our project is important? It shows that we can train high quality captioning models without always needing huge data sets or expensive hardware. We are focusing more on smarter training with smaller and better chosen data sets. Uh, it makes overall AI more accessible and affordable. Our project can benefit a wide range of users, from users from schools, hospitals, small startups, and underserved communities worldwide. Thank you.